Question number 21. A block of mass m is kept on a horizontal ruler. The friction coefficient between the ruler and the block is mu. The ruler is fixed at one end and the block is at a distance L from the fixed end. The ruler is rotated about the fixed end in horizontal plane. What can be the maximum angular speed for which the block does not slip? And if the angular speed of the ruler is uniformly increased from 0 to at an angular acceleration A, at what angular speed will the block slip? So here, in first case, we can say that force of friction is equal to centrifugal force, that is mv square upon r. And friction is given by mu mg. So mu mg equal to mv square upon r. Mm will cancel out. Here r equal to L, and we know v equal to r omega, so that is L omega. So this will become L omega square. So we have got mu g equal to L omega square, from where we get omega equal to mu g upon L, a whole power half. Now, we have got the value of omega as mu g upon L whole power half. Now, case number 2 or case B. Here, if there is angular acceleration also, in that case, net acceleration will change, and that will be a resultant of angular acceleration and radial acceleration. So let's find out. So radial acceleration is L omega square, because we have already evaluated AR equal to V square upon R. So AR equal to V is L omega square divided by R is L. So L omega square will be left. So this is the radial acceleration. Now we have to find out tangential acceleration. So for that purpose, we write AT equal to dB upon dt, but V equal to L omega. So d upon dt of L omega. So L times d omega by dt. And d omega by dt is given as A. So we can say L, and let's write this A as alpha. So L alpha. So total acceleration, A total, will be resultant of AR and AT. So that is L square alpha square plus L square omega square. So we can write it further. Here AR is L omega square, so it will become L square omega power 4. So this is A total. Now we have to find out frictional force in this case. So frictional force, which is mu mg, is equal to mass times total acceleration. So total acceleration is this L square alpha square plus L square omega power 4. Now let's simplify it. So mu mg, here m will cancel out. So we will be left with mu g equals this. From here, this is L square, this is L square, so we can take out L. So L outside, then root of alpha square plus omega power 4, or mu g upon L equal to alpha square plus omega power 4 under root. We can square it. So mu square g square divided by L square equal to alpha square plus omega power 4. And our concern is to get omega. So we can write mu square g square divided by L square minus alpha square whole power 1 by 4 equal to omega. And that is our answer. Now let's go to next question. Next question says, a track consists of two circular parts A, B, C, this and then C, D, E, of equal radius 100 meter and joined smoothly as shown in figure. Each part subtends a right angle at its center. So this angle is 90 degree and this angle will also be 90 degree. Now, a cycle weighing 100 kg together with the rider travels at a constant speed of 18 km per hour on the track. Find the normal contact force by the road on the cycle when it is at point B and D. Here and here we have to find out normal contact force. Then find the force of friction exerted by the track on the tires when the cycle is at BCD. On three situations, BCD, we have to find out what is friction. And then find the normal force between the road and cycle just before and just after the cycle crosses C at this point and at this point. And then what should be the minimum friction coefficient between the road and the tire, which will ensure that the cyclist can move with constant speed. So let's analyze it one by one. So consider the part number A. So at point B, here centrifugal force will act in outward direction, normal will act in outward direction, and weight will act in downward direction. So we can say mv square upon r plus n must be equal to mg. Our concern is to get n, so n will be equal to mg, that is 100 into 10 minus mv square upon r, 100 into velocity, this is 18 kilometer per hour. So 18 into 5 by 18 will give 5 meters per second. So this will become 25 divided by radius is 100. So 1000 minus 25, which is 975 Newton. Now at point D, at this point, weight will act in downward direction and centrifugal force will act in downward direction. And here, normal force will act in upward direction. So we can write the equation at D, mg plus mv square upon r is equal to n. Now we put the values, same values will be there. So n equal to 1000 and in place of minus 25, this time it will be plus 25. So answer will be 1025 Newton. Now consider part second. Part B here, find the force of friction exerted by the track on the tires when the cycle is at B, C, D. At point B and at point D. This is the lowest point, this is the highest point. At this point, there is no chance of slipping. So friction will be 0, but at point C, friction will be there. So let's find out what is the friction here. So here, mg at this point, mg will be in this direction. Here, this angle will be theta, this angle will also be theta, theta here. Since total angle is 90 degrees, so this will be 45 degree. This angle will also be 45 degree. So mg cos theta will act in this direction and mg sin theta will provide the friction. So we can say friction will be mg sin theta. So m 100 into 10 into sine 45 degree, that is 1 upon root 2, 1000 divided by root 2. So 500 root 2. So that will be equal to 707 Newton. Now, next case is, let's delete this. So just before point C, at this point, we have to consider the situation. So mg cos theta will act toward the center, and normal force will act in outward direction, and centrifugal force will also act in outward direction. So we can say n is in this direction, mv square upon r is in this direction, and mg cos theta will act in this direction. So just before C, n plus mv square upon r equal to mg cos theta. Our concern is to get n, so n equal to mv square upon r negative plus mg cos theta. We can put the values. So here theta will be 45 degree because this point is very close to C. So we can put the values. So minus 100 into 5 square divided by 100 plus 1000 into 10 into 1 upon root 2. Theta is 45 degree. So on evaluation, we will get 682 Newton. Now, just after C, at this point, situation will be little different. Mg cos theta will act in this direction, and normal force, normal contact force will be in this direction, and the centrifugal force will also be in this direction. So we can say just after C. So N must be equal to mg cos theta plus mv square upon r. As I told you, that mv square upon r will be in this direction, and mg cos theta will be in this direction. So our relation will be n equal to mg cos theta plus mv square upon r, or here we have already evaluated mg cos theta, and mg theta is 45 degree. This point is also just very close to C. So situation will remain same, except the direction of forces will be changed. So this will be 100 into 10 into 1 by root 2 plus m is 100, velocity is 5 square divided by 100. So this value we have already evaluated 707, and this will give 25. So answer will be 732 Newton. Now, last case, what should be the minimum friction coefficient between the root and the tire, which will ensure that the cyclist can move with constant speed? So for this purpose, so we consider a point just before C, and where we assume that N is minimum. So in that case, we write frictional force, which is mu N must be equal to mg sine theta. Now we can put the values. Just before point C, here we have evaluated that normal force is 682. So mu times 682 equal to m. M is 1000. Sorry, m is 100 into g is 10 into sine 45 degree. Point is very close to C. So this is 1 upon root 2. Our concern is to get mu. So mu will be equal to 1000 divided by 1.414 into 682. If we simplify it, we will get 1.037, and that is our answer. Thank you for watching.